Okay, so this is really easy, right? But there's a reason, a bigger reason why I put this up here. If you're not paying attention to the absolute value bars, and you just are looking at the 6 and the -9, what would you say to answer this? And if I asked you which is bigger, you'd say 6, right, if you're not paying attention. But here's the thing I want to drive home about when you see these symbols right here. Those are actually telling you to do something. Like there's an action involved in those. The action is figuring out how far is 6 from 0, right? That's our absolute value definition. So it's telling you to do something. And so what would you do? What is the absolute value of 6? Right? And the bars are gone. And what is the absolute value of -9? 9. So now when you actually do that action and you have 6 and 9, what's the actual answer, which is bigger than 9, right? Okay. So that's one thing I wanted to remind you of. When you see those bars, it's telling you to do something. It's kind of like the same as if you had this. What is that problem telling you to do? Add. And you're not done until you finish that and you have a final answer. Same thing with the absolute value bars. Okay? They're not just parentheses. They're telling you to do something. They're telling you to find the absolute value. All right? And so I want you to keep that in mind. Today what we're going to do is solve absolute value equations. We're going to take a little bit of baby notes. Where did my thing just go? All right. So at the end of the lesson, we'll be able to do something like this. We'll solve 3 times the absolute value of x plus 2 minus 5 equals 4. That's our goal for today. We're going to start out with a tiny quick review, basically what I just said in the warm-up about absolute value. The first thing we learned yesterday about absolute value was it's the distance of a number from where? 0, thank you. And the answers are always what kind of number? Positive, so it's always positive. And this is true no matter how crazy the number looks. Like if I asked you for the absolute value of -12 and 79/85, what would that answer be? 1279/85, right? So no matter what, because that's the distance from 0. It's a measurement, so it's always positive. Sliding over here onto your notes to the right about absolute value equations, I kind of want to pick up something that was on your worksheet yesterday. Your worksheet yesterday, you did a bunch of these kind of problems, and then there was some multiple choice ones at the bottom, and it asked you something like, which numbers have an absolute value of 7? And you answered what? You would answer what to that question? -7 and +7, right? And so I'm going to write that down again here, and then I'm going to talk some more about it in the context of today's lesson. So the question was something like, which numbers have absolute value of 7? And we answered 7 and -7. Because if you take the absolute value, either one, you get 7. Okay? And that's words, that's a question. But here's what that looks like in mathematical symbols. You feel okay with that being the exact same thing, just in symbols? And what do we call something that has an equal sign and stuff on both the left and right? It's an equation, right? So here's what we're going to be talking about today. We're talking about absolute value equations. And if we took this symbols, absolute value bar x equals 7, we said already, we knew conceptually, and the concept of it was that the answer was 7 and -7. The answer for whatever x could be was 2 different things. X could be 7 or x could be -7. Right? So look at how I've written that, how it's changed from here to here. We started out, we had one equation, had absolute value bars. When we went to figure out the solution to that, I now have these 2 answers. I still have an x, what was inside the absolute value. There's no more absolute value bars, they're gone. And that 7 that's on the right-hand side, that's a constant. We have a positive version and a negative version of that. So what we've done here is we've taken that one equation, and we've written two equivalent equations. That's this step right here that we're about to talk. Okay, the steps for solving an equation, absolute value equation. So the first step is to isolate the absolute value part. That means get it all by itself, which we'll talk more about as the lesson goes on. The second thing is to write the equivalent equations. That's this step right here. And then the last step is to solve. So here's what that will look like in example 1. So example 1 is almost just like, so this equation is pretty similar to this one. Okay, the only real difference is there's now a 5 inside the absolute value. There's like a coefficient there. But what we're going to do is set it up the exact same way. So here, when we had absolute value of x equals 7, we have two equations. Where did that x come from? Was that inside the absolute value or on the right side? Where did this x come from? The absolute value. What's inside the absolute value on example 1? 5x, right? So I'm going to now, instead of have those x's in that place, I'm going to have 5x in that place. Okay, 5x is whatever was inside the absolute value. And then up here we said that whatever's inside the absolute value up here could have been 7 or negative 7. What's in the place of 7 here? Not 5. The 10, right? The constant. Whatever's inside there, that value can be 10 or it can be negative 10. There's two options. Okay. What you really, feel like you're going to want to do, and this is one of the most common mistakes, is to take that, what's inside the absolute value, make it positive or negative. But that's not what's going on. It's whatever's inside there can either equal positive 10 or whatever's inside there can equal negative 10. So you pull out what's in the absolute value, and then you equal positive the constant and negative the constant. And now you can solve. What do we do here to solve? 5 by 5. Yep. So in order to make that equation true, x can be 2 or x can be negative 2. By the way, that's just a coincidence that they're the same number with opposite signs. That's just coincidence. Whenever you get your two answers, they might be the same number, they might be different, they might have the same signs, they might have opposite signs. So this right here is just a coincidence. All right, so that was a baby example. We're going to level up a little bit. So we had 5x inside the absolute value, and we had a constant on the right-hand side. So going up here to example 2, how have we leveled up a little bit in that problem? There's a minus 5 inside the absolute value now. But the first thing I do want to mention, though, is that step 1 is already done for us. Step 1 says isolate the absolute value. Well, here's the absolute value. Isolating it means it's all by itself. There's nothing on the outside of it that we have to fix or take care of. So since step 1's done, we go straight to step 2, write the equivalent equations. So that means we write our two things. We take what's inside the absolute value, we just take it out. What's inside there? 3x minus 5. Take it out, write it down twice. Okay. That can equal two different things. It can either equal 7 or negative 7. And now we have those two equations to solve. So you go ahead and solve yours, please. And I will solve mine. Did you get 4 or negative 2/3? Okay. I'm going to show you how to check this. I'm not going to ask you to check it every time, but I do want you to see why it works, that you can have two different answers to the same thing. Okay, if I were to plug 4 in to x and check it out, I would have 3 times 4 minus 5. Okay, in absolute values, when you're doing order of operations, they're kind of like parentheses. So you work inside there first. So I would do 12 minus 5, which is 7. And what is the absolute value of 7? 7. So is that true? yes, so that one checks. If you plugged in negative 2/3 to the original equation, okay, 3 times negative 2/3 is negative 2. Negative 2 minus 5 is negative 7. And absolute value of negative 7 is 7. So that would check. One solution gives you positive 7. The other solution gives you negative 7. All right? Because that's the two values that would equal 7 on the right-hand side. So if you ever feel like you did your problem wrong, that's how you would check it out. Right? All right, so on example 3, we still have a constant or a coefficient in front of the x and something else on the inside of the absolute value, but now we have this additional thing, a minus 5. So step 1 is not done this time. Step 1, isolate the absolute value. Right now it's not isolated, it's got a minus 5. So how do I get rid of a minus 5? Add it, right, to both sides. Plus 5, plus 5. It gives me absolute value of 4x minus 3 equals 7. And now you write your two equations. Okay, so you take a minute and do yours. A few things to remind you after coming around and sort of answering a few questions. One is that you don't want to make your two equations until you've isolated the absolute value and it's all by itself. Okay, like we wouldn't do it from the very first step. We want to make sure it's all by itself. So now that's all by itself. You take out what's inside the absolute value. Hayden, what's inside the absolute value? Yeah, what's inside the absolute value? Okay, so I'm going to write that down twice with no more bars, okay? Once you go to make your two equations, the absolute value bars are gone. Because right now what we're doing is we're just talking about the value inside. And that's going to equal, absolutely. One's going to equal 7 and one's going to equal negative 7. All right, so then now we solve for x. We add 3 to this side, that gives me 4x equals 10. Dividing by 4 gives me x equals 10 over 4. If you're leaving it in fraction form, you divide by 2's and you get 5 halves. If you're giving me a decimal, that's 2.5, 2.5. And then for the second equation, you add 3 to both sides. That gives you negative 4 on the right. Divided by 4 gives you negative 1. So we've got negative 1 or 5 halves. Yeah, it's not bad. Once you get the hang of it, they just go really fast. Right? Now, on this last equation, true or false, I'm going to set up my positive and negative versions right now. True or false? False. I have to do what first? I have to get the isolate, right? I have to get this all by itself. But right now, here's what's happening to it. It has a times 3, and it has a negative 5. And here's a heads up, like a little warning. Do not distribute that 3. Just you have to resist it. Distributive property and absolute value, they don't play well together. So we're not going to distribute. So pretend like if it wasn't an absolute value, if you had this, you see how this is similar, right? If you're trying to solve for x, what would you do first? Add 5, and then you would divide by 3. That's what we're going to do here with the absolute value, okay? So we're going to add 5, which gives me this, and then divide by 3, which gives me this. And now that the absolute value is all by itself, we set up our two separate equations. Okay. Krislana, what do you think those are going to be? Mm-hmm. Yep. Perfect. Thank you. And then all we have to do on both of those is subtract 2. And we get negative 1 or negative 5. oh, sorry, positive 1. I'm just making all kinds of mistakes up here. Positive 1 or negative 5, okay?